In this lesson, we're talking about the empirical rule with normal distribution. So a couple of terms here that we're going to be talking about and using throughout stats is, so with the normal distribution, so this is like our bell-shaped curve. So basically our data falls into this curve where the majority are in the middle here, and then you have your outlier here on the out. And this will represent, of course, 100% of the data from end to end here with our normal distribution. Then our standard deviation is the spread of the data, so how far it is from the mean and average. So the empirical rule is we're going to focus on the mean, which is the middle, right? So the mean we're going to use as kind of like that 50%. So half of the data is going to be below the mean, and half of our data is going to be above the mean. And the mean, we're going to use we're going to use mu. And for standard deviation, we're going to use sigma. So if there is data that falls one standard deviation above and below the mean, so one standard deviation away, that is 68% of the data. So if you were to look at the formula sheet, this section is 34% and this section is 34%. So if you add them, there's your 68%. So then the next is if I had two standard deviations away. So two standard deviations above and below is 95% of the data. Then here, three standard deviations below and above. So it's the majority, but not all of it. You have 99.7% of the data is within three standard deviations of the mean. So again, the empirical rule we're going to be using here is 1, 2, or 3 standard deviations away. So either you're 68% of the data, 95% of the data, or 99.7% of the data. So here, just to show you, and this is on the formula sheet. So again, we are going to always be given mu, which is again the mean, and standard deviation, which is your sigma. So remember, standard deviation is the spread. So here, let's say, for example, we're talking about test scores, right? A test was taken and the mean test score, the average test score, let's say, was a 75. So we have 75 here is the mean, is our mu. So 75. Then let's say the spread of the test scores, the data, or sigma, let's say was, we have a standard deviation of 5 points. So that means to finish off and create using our normal distribution, the empirical rule. Each of these, so this represents one standard deviation above. So we're going to add 5. So this here represents a test score of 80. So a test score of 80 is one standard deviation above the mean. So then 2 standard deviations above the mean would be 85. We just keep adding our standard deviation of 5. So then 3 standard deviations above the mean here would represent what test score? A 90. Then remember, right, there's also the below. So here, 1 standard deviation below the mean is a test score of 70. So then 2 standard deviations is 65. And 3 standard deviations would be what test score? A 60. So we keep using that standard deviation here to represent the spread from our mean here. So if you notice, what are test scores that represent 68% of the data? 1 standard deviation, 70 to 80. This is 1 standard deviation above and below the mean. So that's how we're going to look at and use empirical rules. So that would be, so 68% of this data is a test score. Students, 68% of the students a test score between 70 and 80. So like here in example 1, we're talking about oak trees, full-grown white oak trees, and they're normally distributed with a mean of 90 feet. So here we go. So we've got our mean here, our mu. So this is 90 feet. We have our standard deviation, our sigma of 3.5 feet. We're going to use empirical rules. So here we go. So again, we're just going to keep adding 3.5. So one standard deviation above is 93.5. So we're just using the standard deviation here. So then two standard deviations would be 97, and three standard deviations would be 100.5. Then also below, right? So one standard deviation below the mean is 86.5. So now just subtracting the standard deviation of 3.5. So then here we've got 83, two standard deviations below, and 79.5 is 3. So now that we've got our curve here, empirical rule, so here we go. What percent of oak trees are between 86.5 and 93.5? Well, notice the 86.5 is 1 below, 93.5 is 1 above. So one standard deviation away from the mean is 68%. So now what percentage of the data is less than 97%? So now we're going to have to include here all of our data. So starting at 97, so here, and less than. So we're including all of this data here, all of this information up to 77. So basically we could add all these percentages up, or if I know that this is 100% of the data, then just subtract these two sections here. So if you were to look at your formula sheet, these two sections are 2.35 plus 0.15, which is 2.5%. So that means if we're not including the 2.5, that is 100 minus the 2.5. Or again, just add all of these up, right? And that's how you get 97.5%. So then the next, what is the percent of at most 83? So at most 83 feet. Well, 83 is here at most. So that means this is the highest. So again, we're just talking about less than. So we're just talking about these two sections here up to 83. So 1, 2. So looking back, again, these two sections here. So this represents 2.5%. So 95% of the data falls between what two values? So here we go. Remember, our empirical rule is 68%, 95%, and 99.7%. 68% is one standard deviation away. 95% is two standard deviations away. And 99.7 is three standard deviations away. So if we want to know 95% of the data, that is how many standard deviations? 2. So what value represents 2 below the mean here? 1, 2, 83. What value represents 2 standard deviations above? 1, 2, 97. So 83 to 97. That's why the answer here is D, because that's 2 below and 2 above. So go ahead and pause the video and try the U-try on your own, labeling the curve, use the formula sheet if you need to, and then let's see what you get. All right, here we go. So here you should have seen that the mean batting average for the Braves was 250. So we're going to start here in the middle. Our mean is 250, our mu. Then standard deviation was 20. So 1 standard deviation above, adding 20 is 270. 2 standard deviations above, 290. 3 standard deviations above, 310, right? Keep adding 20. So to go below, we're going to keep subtracting 20. So 1 standard deviation below is 230. 2 standard deviations below, 210. 1 standard deviation below, 190. Keep subtracting the standard deviation of 20. So what is the probability of having an average over 290? So here's 290 and over. So you should have included these two sections here. And if you look, the two sections represent 2.5%. So 2.5% or 0.025, right? Because this percentage is out of 100. So dividing 100, so you could write it either way here. Now, what percent of the Braves players fall between 210 and 270? So let's see. So 210 to 270. So we're talking about how many sections? 1, 2, 3. So we're including these 3 sections here. So what is the area from 210 to 270? So again, you had to look at here, these 3 sections, which represent the 68% plus 13.5. So 68 plus 13.5 is 81.5%. So 81.5% of the data is in these 3 sections here, from 210 to 270. Then at most, 230. So 230 is here at most. That means that's the highest. So we're talking about everything less than. So we're talking about these 3 sections here. So not the 2, right? But these 3. So here we're talking about, so you should have used these 3 sections, which is 2.5% plus the 13.5. So 13.5 plus 2.5% is 16% of the data. Then 68% of the data falls between what 2 values? So here's one of those percentages again, right? 68% represents how many standard deviations? 1 standard deviation. What's 1 standard deviation below? 230. What's 1 standard deviation above? 270. 230 to 270. That's why the answer is B. So then there's also a few of these practice problems. So if you want to, again, also try these 3 on your own, go ahead and pause the video and let's see how you do. And here we go. So for the first question, you have a mean of $51,000, standard deviation of $6,000 for the salary. So a quick sketch of the curve here. I've got 51,000. I'll just take off the 1,000 for spacing. So this 51, so we're counting in thousands. So here, 1 standard deviation above is 57. 1 standard deviation above is 63. We're just keep adding 6 or 6,000. So then here, 69,000 is 3. Then below, we're at 45,000. Here, you're at 39,000. And here, you should have been at 33,000. So again, subtracting 6. So what is the probability that a person selected, a teacher selected, has the salary between 45,000 and 63? So 45,000 to 63,000. So how many sections were you looking at? 1, 2, 3. You were looking at the one above and one below, which is the 68%. But you also had this section here. So we had our 68%, but we also had 13.5. So 68 plus 13.5 is 81.5%. So here, 81.5%, or you have this value here, percentage out of 100, your percent, and this is 0.815. So then number 2, again, you have a mean 20 minutes. So we'll again set up our curve here. So we've got 20 is our mean, our mu, with a standard deviation of 4. So 1 above, 24, then 28, and 32 is 3 above. Then below, so here we're at 16, 12, and 3 standard deviations is 8. So what is the probability that a person expected would wait 8 to 32 minutes? So 8 to 32. Now you should have noticed this is 3 below and this is 3 above. So this represents 3 standard deviations away from the mean, the spread. So which of these percentages represented 3? Well, A, 68% was 1 standard deviation. 83% is not part of our empirical rule. 95% is how many standard deviations? 2. So 99.7% is 3 standard deviations. So that's why the answer here is D. Then question number 3. We have the mean lifetime for the battery life of 500 days. So our mean was 500 with a standard deviation of 61 days. So here I've got 561, then add another 61. So we're at 622. And then here, 683. Then here below, so now we're going to keep subtracting, right? So here we're now from 61, we are now at 439. So then 2 standard deviations below, you should have gotten 378. And 3 standard deviations away, you should have gotten 317. So now the question is asking 95% of the data falls between what 2 values? So 95%. Well, again, there's one of those 3 percentages. So 95% represented how many standard deviations? 2. 2 standard deviations. So 2 below is 1, 2, 378. 2 above, 1, 2, 622. So here, 378 to 622. That's why the answer here is C.